again, everyone. This is Bob Martin with the Nautilus Dry Docks, and I'm very excited to share with you the completed Alvin DSV submarine that I've been working on for the last few months. If you've been following along my channel, you'll see I've had updates throughout the entire process, but this is the finished product. I'm going to walk through all aspects of it, the cosmetic aspect of it, the drive aspect of it, the control aspect of it, show you how it's put together, and at the very end I'll show you how this submarine performs in the water. So let's start with the cosmetic aspect of the boat. This is a fiberglass kit that's offered by FX Models. It's 1/8 scale. Like I said, fiberglass construction, and when you get it, you basically get the two main shells, some dishes for the window cutouts, the prop shroud, and that's pretty well it. You know, there is a lot of work that goes into converting what you get there into a fully built and accurate replica of the Alvin. But it was a fun process. All of the detail parts that you see here, all of the floodlights, the robotic arm that's fully articulated, all of the hinges, the brackets, the windows, everything was scratch built. And I leveraged use of my 3D printer quite extensively so that I got some very, detailed pieces, as you can see here. The skid plates turned out actually really well. This is plastic backed sandpaper, used two-sided tape and painted it black, and that works out really, really well for a scale appearance on the boat. All of the lights are LED, and the strobe location here actually has a strobe light that flashes intermittently for some additional realism as well. The collection basket is fabricated from brass rod, 3D printed brackets, as well as stainless steel mesh. So that turned out really well. That's positionable and removable as well. Inside, you can see we got a ton of volume inside this boat. Because of that, you need to flood and drain it fairly quickly. And to that end, I put some 1¼ holes in the bottom. And even with that, it takes a good 10 or 15 seconds to drain the hull out. You can see the linkages. This is my main propeller drive shaft. You can see right there, we've got our rudder linkage, and we've got our tilting thrusters. Now, just a note on those, these are actually slightly undersized, but the reason that they are on this model, they came with the kit. This is a Graupner unit that comes complete. But because they're a little bit undersized, that prop is only about 34 or 33 millimeters in diameter. They do not put out a ton of thrust, but fortunately, the ballast system in this boat is very, very precise, and it's very easy to achieve neutral buoyancy, slight positive or slight negative, which means control is exceptionally precise. The other thing is, with that propeller actually swiveling through this arc, you get amazing turning response. I would say you've got a turning radius of about 2 or 3 feet, which is excellent. All of these connectors are waterproof. These are automotive connectors. I get this question asked a lot. This is just from an auto supply store, and you can see the other end of it here in the cylinder. So it's got a seal. It keeps everything waterproof. And this is a different variation of it for the LED lights, and that plugs into this socket right here. So now, with the cosmetic aspect of the boat kind of addressed, let's move on to the control. Now, this is a highly modified D&E Miniatures 3.5-inch diameter cylinder, and at one point, if you were following along with me, this was a single long unit, and this was supplied to me by the owner in the hopes of being able to utilize it. I went off track and I was examining the use of potentially utilizing a watertight box to house my control systems, but I love the way that this turned out. All of these mounting brackets were designed by me and 3D printed. And the assembly, once put together, looks something like this. So it's a stacked unit where you've got your main control and drive assembly on the bottom and a nice large ballast tank on the top. This is a hybrid ballast system, so it actually utilizes a combination of liquid air and pumps, a low pressure pump system. So we vent the tank by using this linkage right here, opens up this vent, all of the air escapes, and the model sinks. When under the water, you give a little tiny burp of the liquid air. It displaces the water, forces it out of these holes in the bottom of the ballast tank. The model becomes positively buoyant. And once the sail breaches the surface, this snorkel is going to be above the water line. And when that happens, you can activate your low pressure pump, and it'll pump air into the ballast system and bring the model up to full surface trim. And what that does is it minimizes your need to rely on the gas system. It's there only to just provide that slight bit of buoyancy to get it from negative or neutral buoyancy to positive buoyancy. So this one reservoir in here would have ample liquid air in it to have a long time at the pond. The cylinder itself has a remote on-off switch. You can see here. It's a key fob control. I love that. Works really, really well, so you don't have to keep opening and closing the model up when you're on your way to or from the pond. I got some steel ball bearing servos in here. Twin air pumps, as I said. Twin because I wanted more volume of air going through there, so it didn't quite take so long to empty the ballast tank. I have a separate battery eliminator circuit, so that's a 5 amp, 5 volt power unit for the receiver and all the peripheral units. Just a really nice cylinder. I'm really happy with the way that it turned out. The main drive unit is a sealed lead acid battery, just like you would get in a motorcycle or a garden tractor. This one is 8 amp capacity, 12 volts. The only thing that needs to be sealed up are the actual leads on here, and even then really it's just the positive lead that you need to worry about. So some simple silicone does that, and then we got a waterproof connector here as well that connects on the inside of the boat to provide main power. Control comes from this handy unit. Now this is a VEX 6-channel radio. These are offered for sale on my site. They are cheap and intensely powerful little radios. I am getting to love these more and more. It's fully computerized. You can adjust endpoints, servo reversing, you can adjust scale, and then it's all digital trimming. So it's a really powerful radio, and like I said, 6 channels, which is ample control for almost any remote controlled submarine that you would need. So now that we've taken a look at the boat kind of as a whole and all of the components that go into it, let's take a quick look at how it all goes together. All right, I'm going to try and show you how everything goes together here as best I can. We're going to start out by putting the main drive battery into the keel of the boat, and it basically just sets in place here. The two mounting bulkheads keep it pinned in place. I'm going to push the power lead out of the way, grab our main drive section in here, and we're going to set that in place as well. I'm going to take the dog bone connection, get that connected, and then you pull the battery until this bracket falls into place, and it gets pinned down by the cylinder. Take a standard Phillips head screwdriver, and we'll find our hole here. That's all stainless steel hardware, so it won't rust or corrode. And again, there's 4 of them that hold it down to the base. So, take our linkages, and these are ball and socket nylon connectors, and you just snap those in place. That's for our rudder and for thrusters. Take our ballast system, we're going to set that in place. Four hold downs there. And what I want to point out to you are these wings that I've got on the ballast tank, and at the very tip of those you've got a pair of magnets, and what those are designed to do is trap this flexible drive shaft against them to stop vibration. I found during my experiments with this setup that it certainly worked, but that the drive shaft would vibrate during operation. These magnets keep it tight and keep that operation very, very smooth without the need to put clips or harnesses in place to do so. With that done, what we're going to do is going to take our ballast hoses, we're going to feed these through these bulkheads on either side, up through the holes, and these are all labeled in and out. So out goes on the bottom, in on the top. And again, this kind of makes sense when you take a look at the plumbing. So in, you're drawing air in from the snorkel, goes down into the pump, and then it blows it out into the ballast tank. We are going to now grab our thruster power lead, snap that in place, our lighting power lead, press that in place and screw down the retaining cap. We're going to connect our ballast servo. Now that is a standard connection. This needs to be greased on a regular basis to prevent corrosion. So with that done, basically everything is all in place and ready to go. The only thing we haven't done is connect our main power, and we're going to wait to do that last. We'll take our receiver antenna, we're going to feed that underneath around the perimeter of the base there. Now underneath our main hull, on the for the top, we've got a lead, and that's for the LED lights. I'm going to connect that to the power lead coming off, and basically everything is together now. So let's connect our main power, and we'll turn on our radio. And our LED lights are on. Upper hull, main unit is powered up and ready to go. Let's take a look at some of the functions here while we're on. We've got our throttle, and that's limited. You can actually, it's at about 50% of maximum output for that speed controller. I find this gives a nice scale speed. We got our rudder control. And what I'll notice when I do the pitch control, they are not engaged until I actually press up or down on the control. And when I do so, the thrusters will kick in both up and down in the same direction, so pushing. And I had to build a bridge rectifier in order to do that because a speed controller is controlling it, and that basically means that the shaft will spin in the same direction regardless of which way I put the stick. So let's take a look at that. So you can see nice smooth operation on that. They actually work really, really well. We've got our ballast control, and I'll see if I can zoom in on that for you. So you'll see a piece of pink styrofoam in there. That's actually what's called a gas saver. So when that tank is empty, the float is down and the plunger will not actually activate the gas blow, but when the tank is full, that's up and it'll actually depress that plunger, allowing gas to escape into there. Other direction vents the tank. That opens up the vent at the top. And the last thing is the air pump. You can see it expelling some of the water that was in that tube. And I got some nice suction on the top. So there you go. That is the sub overview. Last thing we need to do is put the top onto the base. And to do that, we simply drop it over the snorkel, tuck in our cables, and slide it forward until it's in place. Now, in order to secure that in place, there is a screw that goes in the back of the sail, and I'm going to make sure that you guys can see that. And that is something that you can actually just do with your finger. No special tools are needed. That holds that tightly in place. You can lift it up. And then we've got a magnetic cover that just sticks right in place to cover that up. Make it look much more like the real thing. So there we go. This is the completed and ready to operate boat. You can see its little strobe light flashing there in the front. Turn the lights off so you can see the LED lights a little bit better. Now that it's all together, it is ready for the pool. Let's take a look at how things did during the initial testing. Well, there you go, everyone. This is my good buddy, Alvin, all complete, done, and ready for its new owner. The pool trials went exceptionally well. It's an exceptionally easy boat to drive, very good control, nice and smooth operation, and it is just a blast to tool around underneath the pool. So thank you for joining me. Hope you'll join me for many other projects in the future. The next one up is the completion of the refurbishment of a US Gato class submarine. Hopefully you'll join me for that. Thank you for joining me. We'll catch you next time.